These are the most common double angle identity problems where basically you're given what's often on the right hand side and you got to recognize it and then kind of work it backwards. There are other questions, including proofs, where you use the double angle identities, but these you might call a simplify type question, and they are the most common. So this first one, A, 2 sine 0.45 cos 0.45, you got to kind of recognize where is that in the double angle identities. And when I look at the formula for sine 2 theta, that's where I see it. Sine 2 theta equals 2 sine theta cos theta. That's what this looks the most similar to. So I got to recognize that theta is being replaced by 0.45, and then I'm going to sub that into the sine 2 part. So this becomes sine 2 of 0.45. So instead of going left to right, it actually goes right to left. And then we are just basically working that out. 2 times 0.45 is 0.9. If I want, I can actually verify this by punching in sine 0.9 on my calculator, and I get 0.7833, etc., etc. Then on the calculator, also put it at 2 times sine of 0.45 times the cosine of 0.45, and you should also get 0.7833, etc., etc. So I know this is the right answer. For b, cos squared minus sine squared of 5, well, what I want to do is, where do I see this up above? So again, I see cos squared minus sine squared as cos 2 theta. So theta is being replaced by 5. So I'm going to go to the left and change cos 2 theta to cos 2 times 5, since theta is 5. This is cos 10. You can punch this into the calculator and you get negative 0.839. Put in cos squared 5 minus sine squared 5. That's a little bit tricky. So on your calculator, you got to go cos 5, whatever that equals, square it, minus sine of 5, square it, and then equals. And you should get the same thing as a decimal. So nice thing is we can verify all of these on the calculator. For part C, we have 8 cos squared of 6x minus 4. Remember, any of these that are squared, it's really the cos of 6x all squared minus 4. So what's important here is that 6x is inside of cos. You cannot factor anything out of it, and we wouldn't even try. The 8 cos squared 6x is all one term. So the biggest mistake that people make is that they often, like, this is going to require factoring, and they often try to factor out of the angle, and you can never factor something out of the angle. So when I look at this, the most similar identity up above is the 2 cos squared minus 1, and I want to make it look like that. So I'm going to basically force it, no matter what. I'm going to go, okay, to make that 8 a 2, I need to factor a 4 out. So I'm going to factor a 4 out of the whole thing, and I end up with 2 cos squared 6x minus 1. When I expand this, if you want to check, it's really just the 4 times the 2 is the coefficient, okay, of the whole cos squared 6x. You can never again take anything out of the angle. So the 2 cos squared 6x minus 1, now it's kind of obvious that theta is 6x. So I'm going to work just inside the brackets, work that back to cos 2 times theta, which is 2 times 6x. The 4 just stays outside. And then 2 times 6x is 12x. So you get 4 cos 12x. This isn't the easiest one to verify, but if you do want to verify it, just sub a number in for x. Just say it's 2. And then 12 times 2 is 24. So I'd go 4 cos of 24. And then same thing, sub 2 in for x in the original. 6 times 2 is 12, so I'd go 8 cos squared of 12 minus 4. See that they're the same decimal, and I know it's the right answer.